this is John from caveofprogramming.com. In this tutorial we're going to look at the right bit shift and binary, bitwise and operators. The reason for that is at the moment we've got this particle explosion that we've been working on in these tutorials. But before we start fine-tuning the movements of the particles and make it look nicer, I think it would be good if we could blur this program, because without seeing the kind of blur on the particles, it's hard to really get a sense of how this is going to look with the final blur applied to it, and the blur makes a big difference in how nice it actually looks. Now, to actually do the blur, we need to be able to get pixel values and set new pixel values based on the old ones after applying some kind of blur algorithm. And to get the pixel values, that involves getting a color, which will be a 32-bit value that looks something like this. Let's write it out in hex. 1, 2, 3, 4, 5, 6, 7, 8. And getting the red, green and blue values from this. So we're packing red, green, blue and alpha values into a single 32-bit color value. So this would be red, this byte would be green, this byte would be blue, and this would be alpha. And we're not using alpha, although we have to have it in there because we're working with 32-bit values for each pixel. So to show you how to do this, well, let's get rid of the alpha value just because it's simpler to demonstrate this without. A little bit simpler. How can we get the red, green and blue values out of there? So the red is 12 in hex, green is 34 in hex, each of these is 1 byte, and the blue is 56 in hex. How can we extract those from this? Well, one thing we can do is use a bitwise AND operator. If I write int, let's say red equals color, now I'm going to use a single AND. So two AND symbols together in C++ is a logical AND. It's like Boolean logic. But if I use a single AND, this does a bitwise comparison. So if I write out now OX, and we're going to set, if you imagine this is binary, I'm going to set 2 bytes entirely to 1 byte entirely to ones. So this is like 8 ones. FF is like 8 ones in binary. And then the rest I'm going to have zeros. So I've got the same number here, but if you look at it in binary, it would look like this: 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And what this bitwise AND will do will be, it will look at each bit in this and this, in the color and in this, my what we call a mask here, and it will say, okay, if both of the bits are 1, I'll set the bit in a resulting variable to 1. But if either of them is 0, then I'll set the corresponding bit in the resulting value to 0. So it means AND means both of them, the actual value and the mask, have got to have ones set in a particular position. So it's got to be 1 and 1 together. If it's 1 and 0, then we say that's we're going to set that to a 0 in the resulting variable. So like here, if I write out, if you imagine this is the mask, we call this the mask, which is this. And if we say that this is the color, so let's line them up here. If the color looked like this, then the result of bitwise AND will be like this. So if we look at this column, we've got 1 and 1, so that's 1. This is 1 and 0, so we make that 0, and these are all 1s and 0s. Here we've got a 1 and a 1, here's a 0, here's a 1 and a 1, a 1 and a 1, 1 and 0, that's 0, so that's 0, 0, and in fact all the rest are going to be zeros because we've got zeros in the mask. So it's going to end up looking like this, if I've got this right. So you've got to have 1 in the mask and 1 in the color. Now we're working with hex, but the way this looks in hex is if I use a bitwise AND on this colour with a mask that has FF here and 00 for the rest, all of these are going to be set to 0, and the first two here, which we do the AND operation with the FF, which is just 8 ones basically. This bit is going to remain what it is currently. So let's just see the result rather than talking anymore. I'll probably explain this about as well as I can now. So I'm gonna say here, cout. We want a hex format, and I'm going to output red here. Let's see how this looks. So if I run this now, whoops, I think I've just run the wrong program. Oh no, we've run the right one. So we can see that we've picked out the 1, 2 and set the rest to zeros. All I have to do now is shift this. So if I shift this 2 bytes along, which is 16 bits, now we're going to get the red value. So we've got red. Similarly, if I copy this and let's say green, so let's set the first 2 to 0, and then we want FF to mask out the green bit, and then 00 for the last value, and I want to shift this by 1 byte. And let's take a look at that. So green here, and there's our green value 34, which is picked out from here. And finally we've got blue, which just is colour bitwise AND, so single AND, OX0000FF. And if we now look at blue, hopefully this will work. Whoops, it's good, okay. So we've got the blue value picked out there. Now this is a solution that I've seen on the internet when I've looked for this, but I find that at least what I can do on this system, and I think it would work on all systems, but I'm not completely certain, is we can do the following. I'm going to write a comment there because I haven't tested this on a range of systems. I don't see why it wouldn't work on any system that you try it on, but there's that little doubt in my mind, so I'm probably going to stick to using this kind of system in this tutorial. Now of course we don't want ints here, we want unsigned chars, because each of our red, green and blue values are actually they can only range from 0 to 255, like an unsigned char value. So this is outputting the capital V because it's trying to output it like a character, but if we cast our blue to an int there and then run it, we should see that we're still successfully getting blue. I don't know what this problem is that I keep seeing every time it comes past, maybe just an unused variable warning. Let's check the red as well and check that we're picking out the value 1, 2 there. Let's run this. So yeah, that still works fine. But what I find is that I can do something like this: unsigned char red, let's call it red again, equals, we take our colour and all we have to do is do the shift. So if we shift this by 2 bytes and then output this value, so red again, then if I run this again, we get 1, 2. So because we're using an unsigned char, if we just shift this over, if we shift this number over 2 bytes, sorry, this number, when we shift it we discard all these, and then when we pack the ints into an unsigned char, when we do a typecast in effect, then we end up with the value that we want. So if you're purely getting your result in an unsigned char, I don't think you need to do the mask bit. Nevertheless, I ran through it because I'm not absolutely 100% sure that there's not some quirk on some system somewhere that would somehow prevent this working with some compiler. I don't know. And because you see this on the internet a lot, and also because it is important to know about the bitwise and operator in C++, it is sometimes very useful. There's also a bitwise OR, which I'm not going to cover here, except to say that bitwise OR would set the 1 in your resulting value to 1 if either the mask or the original kind of value were 1. So it's saying it's got one of them has got to be 1, either the first one's 1 or the second one 1. Whereas the bitwise AND says this one's got to be 1 and the second one's got to be 1 as well. So that the bitwise OR, it looks like this. Let's just write this. Bitwise OR. It's that symbol there. And remember, for a logical OR, use a double bar. Okay, so it might be worth Googling bitwise operators, just to have a look at a page there. So if you want some homework, I'll give you that as a kind of homework task. But apart from that, I'd recommend trying this for yourself and check that you can extract red, green and blue values from a 32-bit color like this. Check that you can do it. And then in the next tutorial, we can go on to implementing blur, I should think, which will start to make our program look really quite lovely. So that's it for this tutorial, and until next time, happy coding.